So in this homework you practiced with Spark, and the question number 1 is about installing PySpark, Spark and all the environment. Yeah, so this is, let me just copy one of the things we did. So I took this 04 PySpark, and then I will just copy everything from here and execute this. And what we were asked to do is execute this Spark version, and for me it prints the version of Spark. So this is just to make sure everything was installed correctly and everything works. So this is the version of Spark I have, you probably also have, and we also started, I think, master. Yeah, it opens. Yeah, and so this was the question number 1, and now we need to download this for high volume for higher frequency, high volume for higher vehicles for February. I already downloaded it. I have it already on my computer, so let me check if I have it. I do have it. Yeah, so I have it. Now I just need to read it, and I need to read it, use the same schema as we did in the lessons, and repartition it to 24 partitions and save. I will just reuse the same code as previously. So here, yeah, first we need to import the schema. Let me add this import here. This is the schema. And yeah, so now I read this, then I repartition, and yeah, execute that, and then I write. And I will write to data for higher vehicles, high volume. Then actually I need to execute this February, right? And then write it to February. And I think I already have something here. Yeah, perhaps I have something. Data, and then okay, I wrote it to Parquet, and then I wrote it to this one, and then yeah, and then the rest is the same as here. I already executed this code previously, and yeah, we have this, and this is the result of executing this thing. So I don't want to execute it right now because it will take some time. So that's why I will just look at the size of the thing that I had previously. So this is the size, 208 megabytes, and yeah, this thing here. I know some of you had different answers, so you had some answers that did not match any of the answers. So I asked you to select the closest one. And I think the reason it wasn't exact is because maybe you have a different version of Spark, maybe you have a different environment, maybe you're running this on Mac. And perhaps, so when we do data frame write Parquet, there is this thing compression. Right? And maybe for different versions of Spark, there is different compression. So this one we use is Snappy. You see it says here, so this is a compression algorithm that is used for Parquet, but yeah, it can be maybe different for different versions of Spark. Maybe if you have a different processor, maybe it's better at compressing things, I don't know. But yeah, you should get something close to this. If you didn't, if you executed the same code as I executed here, so let me just put everything in one cell. So if you executed the same code as I executed here and you got a different answer, let me know, and I will also accept that answer as well as correct. So just show me the code if it was the case. Anyways, that was the answer to question 2. And now we need to do question 3. So we need to count records. And I'll close this too. And for that, I will read this data that we just created, or I created some time ago, but you just did this. So I'll do data frame Spark read Parquet, and then this thing here. Something is wrong. Yeah, because it should be Parquet, then of course. Yeah. So this was the location where I saved previously. Okay, and just to check that it works, I'll do data frame show. Yeah, seems to work. So we need to count records, how many trips we had on this date, and I'll solve it in 2 ways. So the first way will be using plain Spark without SQL, and then the second way I will use SQL for that. Let me copy it. And yeah, it says consider trips that started on February 15th. Means that we only look at pickup date time. So we are doing question 3, right? It's question 3. Yeah, so the first thing I will do is I'll turn pickup date time into pickup date. For that, I will import PySpark functions. SQL import functions as capital F, and then here I will do yeah, I'll keep dot here with column, and then the column will be pickup date, and then the value will be F to date, and then this. So as a result, what we'll have will look like that. Actually, don't remember what was the format I used before. Yeah, before I put dots, yeah, like that, right? So let me follow the same format. Yeah, so we have here, we have pickup date, and now we need to group by this pickup date. So I'll do group by pickup date, and then I will select well, we need to do count, right? So I'll do count. So let's execute that. And yeah, I think this is one way of doing this. Coincidentally, this showed as the first one. And I think we have this here, this answer. But actually I wanted to do it differently. So I wanted to do filter. And then in filter, I would do, I'll use the double quotes because I will put the date in single quotes. And then we don't need group by. So we just do filter. We select all the records that for which pickup date is this one, and then do count. And yeah, we don't even need show because it will immediately return us the number of records. So this is an action here. It just returns an integer. And yeah, this is the same answer as previously. And now I want to do the same but with SQL. For that I'll need first to register this table. I will register it the name will be this one, then 2021-02. And now I can execute SQL queries on this Spark SQL, and then I'll have a query here. So for example, select, I don't know, count 1 from this table. So now we'll get to add show. Now we'll get the total number of records, but we also need to add a where clause where this pickup date time, and I will turn this to what is to date equals or 1 equals to this one, and execute this. And this is actually the same thing as doing this one, right? And we get the same answer. So the answer to question 3 is this. And now longest trip for each day. So now we need to calculate the duration for each trip and then see trip starting on which day was the longest, or on which day the longest trip started. Let's formulate it like that. So it's question 4. I'll call just Q4. Yeah, here I will again do it in 2 ways. First with Spark, and then with Spark SQL. So we need to calculate the duration, right? So we need to see for each trip we need to calculate the duration, and for that we need to subtract pickup date time from drop off. So it's columns. So from drop off date time we need to subtract pickup date time, and we will get duration. So let me do duration and just do show. And you see that for this trip the duration was 21 minutes, for this one 18 minutes, 24 minutes, and so on. So now we have duration, and we just need to do group by date. I think I still need to have this column. So we need to group by this pickup date, right? And then for each pickup date we want to find the maximum duration. So we'll do max duration and then show. And now it says that there's a problem. Duration is not a numeric column, and aggregations can only be applied to numeric columns. And it is indeed not numeric. If I show you, if I do this one more time, you see that, yeah, this is, I think this is a Python object that is called time delta. So it's not a numeric object, it's a time delta. And Spark just doesn't know how to take max of that. We can help it a little bit, and we can turn this drop-off date time and pickup date time to Unix timestamps, and we do this by casting this to long. Let me, not lost, but long. Let me show you how it looks like when I do this casting. So for example, this drop-off date time turns into this thing. So this is like a number of seconds from January 1st, 1970, something like this. But this is a standard way of doing for specifying timestamps in Unix-based systems like Linux, macOS, and so on. And yeah, and then if we cast this to long, then we have a numeric column, and then actually we can do max and so on. So it will not complain when we do this. So we just need to cast and execute this. And now we have the answer, right? And yeah, it's not sorted yet. We actually need to sort it. So let me do order by, and then I will order by this max duration. And yeah, we want to have the longest one first, so we will need to do ascending false. And yeah, this is the answer. So on 11th of February we had the longest trip. So this is the answer. And I think one more thing we can do is just limit, let's say, to 5. So we don't have all the days, we just have 5 of them, the longest ones. Let me do the same thing now with SQL. So I will copy this thing. Yeah, I'll copy this thing, and we need to do a group by here. So I'll have this thing here. So this will be the pickup date, right? And then max duration. Yeah, we select from this one, and we do group by, I'll call it as pickup date, so we can group by it. And we need to order by, we will order by this thing. Let me be consistent, so I'll use numbers throughout. So group by the first thing, order by second, desk, and then we'll do limit 10. Right? And then of course it doesn't know what duration is, so let me take this one, and it will be as duration. And here the syntax for casting in SQL is cast, then the name as long, and then cast name as long, something like this. Let's see. Yeah, we get the same answer. Yeah, so on this day we had the longest trip. Actually, I don't know if it's milliseconds or seconds. I think it's actually seconds, because for milliseconds that's just a too short trip. So we can actually, if we want to see this time in minutes, maybe what we can do is we can divide it by 60. Okay. That was a pretty long trip. I don't know how many hours was it. Maybe there is some mistake in data. This is a very long trip. Anyways, so this is the answer to question 4. It's 11th of February. Then question 5 is most frequent dispatching base number. What's happening? And it's question 5. And for that, I think we can just take this query. With SQL, it is quite simple to do this. So we select this thing, and then we select count. We select it from this table, then we group by first, order by second, and yeah, let's limit it. Well, let's take the first 5. And yeah, here is the answer. And yeah, this is the most frequent one. but the question is actually how many stages this Spark job has. So let me add this here. Right. And to answer this question, we need to go to master UI. And yeah, so this was the last thing we executed, and we see that it had 3 stages. You maybe have different number, and the reason you have a different number maybe because you do not have limit at the end. So if I remove limit and execute this, I will have only 2 stages. We can actually, you see there is one task less. We can see what is inside. If we look at DAG, yeah, so it was doing group by, preparation group, then actual group by and reshuffling, and then this take ordered and project. I think this is because of limit, right? Yeah, so without limit, we have only 2 stages. With limit, we have 3. I think if I remove order by in my experiments that I did previously, let me try running it. So without group by, it is 1. Yes, this is quite interesting. It's job ID 31. Let me execute it one more time. So yeah, you see it did number of things. I'm not sure actually what is going on here, but I see that yeah, it was skipping some things. Yeah, apparently maybe because it did need to reshuffle, it just or maybe it used cached results. Actually, I don't know why in this case when we remove order by, it's doing this in one stage. Yeah, but you can see that you can put 1, 2, and 3 here. Yeah, so this one would be with 2 stages and with limit 3. So keep this one. Yeah, this one. And I will now implement the same thing, but with without SQL. Okay, let me. I don't know how useful that thing will be. Probably not so much. Yes, so dispatch and base num. So we do a group by dispatch and base num, then we do count, and then we order by count. Actually, let me look at the results. Yeah, we group by we order by count next. I'll just copy it from here and do limit 5 and show. Count. And this thing will also have 3 stages, I think. Yeah, so it has 3 stages. So this is how you do it. So the answer to this is 3, but if you selected 2, it's also fine. If you selected 1, as we saw, I'm not exactly sure what's happening there, to be honest, because I think it was doing a bunch of ticks here. But yeah, if you selected 1 here, it's also fine. Okay, so the next question we have is the most common location pair. So let me put it here. Most common location pair. And yeah, for that I do not want to use this way of doing things at Spark. I just want to go with SQL because it's with joins it's a little bit complex. And actually, speaking of joins, we will need to join it with the zones table, and this is something we did here in test. So this is the very first time when we run PySpark. We downloaded this lookup table and then saved it to zones location. So let me now read this. So Spark read parquet zones. So data frame zones. And oops. Yeah, this is how it looks like. Let me just keep the column names. And now I want to join this table that we have. Let me now, for now, do select star from this table. I will remove these things for now. So I will take this one and I'll call it, I don't know, for hire vehicles, and I do left join with zones. I forgot to register a temporary table. I'll call it like that, zones. And yeah, first I want to join pickup application. Let me check the names. So first I want to join pickup location ID with location ID and then drop off location ID. So for this one it will be pickup location. So it's a bit cryptic, well, just like that. Pickup location, and then I will join in on for hire vehicles pickup location ID equals this one location ID. So let me see if it actually works. Yeah, it works. And then I need to do another join. And then another join will be on drop-off location ID. So here I'll replace the pickup with drop-off and this one as well. And yeah, I think that's all I need to do the joins. And yeah, here there was a bonus question about join type. So here I'm not asking about left or right join or inner or outer join. I'm asking about whether it's a broadcast join or it's a merge sort join. And we can see, so now let me refresh it. And I will execute it one more time. And we see that we have this broadcast, right? And then for this join, we have only one stage, right? So answer to this question, it's broadcast join. So we broadcast zones to the executors, and then we do join on the fly. Right? So we don't, if we open it here, it's just one stage, right? We don't have any merge sort joins here because zones is a small table. But yeah, now we actually need to figure out what is the most common location pair, right? For that, we will first select, let's concat. We will now need to build this location pair. So it's pickup location zone. Then I'll concat it with slash, and then drop off location zone. Yeah, so we have these zones. Now I'll call it as pickup drop off pair, body name. And yeah, the question is actually asking us to find the most common one. So we need to do group by this pickup dropout pair, and we also need to do count, and we need to order by, yeah, so I'll just copy this thing. So we group by the pair, and then we order by count, and it's descending, and we take the top 5. And we execute this. And we do not see it here, the complete answer, but this is East New York E, which is this one. If you want to see the actual results, you can do take 5 or collect, and it will return the rows. And now we'll see the full name, which is East New York, East New York. So this is the correct answer. And we already talked about this bonus question. This is a broadcast join because the zones table is a small one. And I will not attempt to do this join with this syntax because yeah, with joins I prefer to do it with SQL. Okay, so that was it for the homework, and see you soon. Bye.